In this video, we will take a closer look at some of the more common aggregates that are available within Axiom. We can change the aggregate a trend uses by opening the Edit Trends menu, selecting a tag, and modifying its aggregate kind property. By default, tags that have a float or integer data type are set to use the time average 2 aggregate. Tags that are of a Boolean or string data type are set to use start bound. The time average aggregate is not a mean average, but a time-weighted average. For example, if a tag's value were 10 for 50% of the interval, 20 for 30% of the interval, and 15 for the remaining 20%, the value would be calculated as follows. The mean average will be calculated like this. If wanting to find the mean average, the user can use the average aggregate. Most of the aggregates listed are those established by the OPC Foundation. Some are custom created by Canary. Let's take a moment and review some of them now. We'll start with start bound, end bound, and delta bound. Start bound is the value at the beginning of the interval, end bound is the value at the end of the interval, and delta bounds is the difference between the two. On our chart, I have added the same tag 3 times. Using a float label, I'm showing what aggregate we are using for each one. Each trend is using a 10-minute aggregate interval. End bound minus start bound equals the delta bounds. Similarly, we can find the max and min value throughout the interval and find the difference between them. We'll set the top tag to maximum 2, the second tag to minimum 2, and the third to range 2. Range will return the difference between the max and min value. Some aggregates will output a duration. This duration is measured in milliseconds. A common use case might be determining how long a status tag has been in a 0 or non-zero state. We have the state tag on our chart that bounces back and forth from 0 to 1. Let's set it to use the duration and state non-zero aggregate. We'll set the aggregate interval to 1 day. So this will return the number of milliseconds this tag has been in a non-zero state for the entire day. We're currently looking at a 1-hour window. Let's look at 30 days so we can see what is returned for each day. The last set of aggregates we'll review are the total aggregates. These aggregates are typically used in conjunction with tags that measure some sort of rate. For example, if I have a tag that measures trucks per day, I would use the corresponding total per 24 hours aggregate. Or, if I'm measuring a flow rate that is recording gallons per hour, I would use total per hour. These aggregates first find the time average rate over the given interval, then multiply that average rate by the interval. The bottom 2 trends show how that calculation is being made. In this example, I'm demonstrating the total per 24-hour aggregate over a 7-day interval. The first trend is displaying the raw data. The second finds the average rate over the 7-day interval and multiplies it by 7. This is what we would expect the total to be for each 7-day period, given these raw values. If the user is simply wishing to sum all the raw values together in a given interval, the sum aggregate will accomplish that.